We now discuss the solution of a problem from the section Binomial Theorem and its applications. The present problem is on a binomial expansion in a given context. The present problem has appeared in JEE Main exam held on 25th July 2021 in the morning shift. The problem is if b is very small as compared to the value of a, so that the cube and other powers of b by a can be neglected in the identity 1 by a minus b plus 1 by a minus 2b plus 1 by a minus 3b plus etc. plus 1 by a minus nb is equal to alpha n plus beta n square plus gamma n cube. Then the value of gamma is given by 4 options are given, and each option is in terms of a and b. And it is a very simple and straightforward question. We are given b is very small when compared to a, and b by a whole cube, b by a whole power 4 and the other higher powers of b by a are neglected. Now 1 by a minus b plus 1 by a minus 2b plus 1 by a minus 3b plus etc. plus 1 by a minus nb is equal to sigma k is equal to 1 to n of 1 by a minus kb, and that is written as sigma k is equal to 1 to n a minus kb to the power of minus 1. And now sigma k is equal to 1 to n, a is taken out. A is taken out. When you take a out, it will come out as a inverse, and your in brackets will get 1 minus k into b by a whole to the power of minus 1. Now we expand by the binomial expansion, and that 1 by a is taken out, and now we take the binomial expansion. 1 by a sigma k is equal to 1 to n into 1 minus k into b by a to the power of minus 1. The binomial expansion is 1 plus k into b by a plus k square into b by a whole square plus k cube into b by a whole cube plus k power 4 into b by a whole to the power of 4 plus etc. But we are given that b by a whole cube, b by a whole to the power of 4 and the higher powers are neglected because b is very small when compared to a. And when you neglect it, we will get 1 by a into, and when you neglect, these terms will go away and the sigma will come inside. 1 by a into sigma k is equal to 1 to n 1, that is 1 is to be added n times, plus sigma k is equal to 1 to n k, that is the sum of the first n terms into b by a, plus sigma k is equal to 1 to n k square, that is 1 square plus 2 square plus 3 square up to plus n square into b by a whole square. And 1 by a, when 1 is added n times, that will give you n, and 1, 2, 3 up to n when added, the sum of the first n natural numbers, that is n into n plus 1 by 2 into b by a, and this is sigma k is equal to 1 to n k square is n into n plus 1 into 2n plus 1 by 6 into b by a whole square. Those values we will put here. Now we take 1 by a inside, that is n by a plus n into n plus 1 by 2 into b by a into 1 by a b by a square plus n into n plus 1 into 2n plus 1 by 6 b square by a square into 1 by a b square by a cube, and that is given to be equal to alpha n plus beta n square plus gamma n cube. What is the question? The question is, what is the value of gamma? That is, we equate the coefficient of n cube from this identity. So on the left hand side is n here, n square into 2n, that is 2n cube by 6. That is the numerical term into b square by a cube. B square by a cube. Now gamma is equal to the coefficient of n cube, that is 2 by 6 into b square by a cube. And 2 by 6 is 1 by 3, that is b square by 3a cube. Now let's look at the options. Our answer b square by 3a cube appears against the option 2. Therefore, our answer is option 2. So that is the solution, and I hope that you have understood the solution of this problem. And binomial theorem and its applications is a very important section, and work out some more problems on these lines. I wish you all the best. Thank you.